Hey guys, how's it going? Today we're going to solve three problems and let's start with the 1200 rated one. So before we start, let's see what did we do last time. So we did this one. Let's see if we remember these problems. Favorite permutation. So this was build permutation expression. I remember this problem. A number of integers such that z is a factor of x or y. So number of integers such that the XOR of x or y. Let's revisit this problem. Okay. So Shahag has two integers x and m. Help him count the number of integers. One is less than equal to y is less than equal to m such that x does not equal to y, and x or y is divisor of either x or y or both. So I remember this problem. Let's see. X does not equal to y, and x or y is the divisor of either. So such that or x or y So x is 6 and m is equal to 9. So we will see the numbers that are divisible after you perform x or y. So six is this, right? And so how are we supposed to solve this now? So how are we going to manipulate these XORs? Let's see what we have here. So basically, get its factors, and then So the case one is m is smaller than or equal to x. So in this case, we're going to have stuff like let's say I have a number such as 1001 and I XOR it with, let's say, 1111. What happens? The number that comes out is 1100. Now let's say that our y is greater than x. The MSB of what? MSB is greater than MSB of x. So what happens in that case? Nothing happens, right? Why? Because x XOR y is going to make a number bigger than x. So it's not going to be divisible, right? It's not going to be divisible. But if we have x XOR y, and in this case the number is going to be pretty big, right? Would that number be divisible by y? And the answer to that is so in this case the answer is going to be 1001, right? I'm sorry, it's going to be 1 and then another 1, then we have 0, and then we have 1. So this is also greater than y, right? Now is it possible to have a number such that, let's say we have 2 or 4 or 8 or 16? So is it possible for us to have a number such that MSB of y is equal to MSB of x XOR y, and also x XOR y is a factor of y. Is this condition possible? So what we know is that x is 1e6, right? 10 to the power 6. So if we have y from 1 till x, we can just do a brute force solution, right? But if we have y that is greater than x, what do we do in that case? So when is a number divisible? Is when is one number a factor of another number? If we are talking in terms of binary, how do we devise that? So let's say I have something like 1 0 0 1 0 1. Right? So let's just do this instead. So this is what? This is 2 to the power of 2 1 2 3 2 to the power, sorry, 2 plus 2 to the power of plus 2 to the power 5, right? 0 1 2 3 4 5. Now this is one number, and if we were to find a factor of this number, what would that factor be? So that factor would be 2 to the power 2, right? 1 plus 2 to the power 3. This is your greatest factor right here. Is it possible? So let's say that I have something like 1 0 0 0 0. In this case only, in this case, we can have y such that, sorry, we can have x XOR y such that it becomes this number right here. That is not possible. It is not a divisor. Or is it? I think it's not. This question was poorly phrased, right? That's why C here is an integer, but C can't be 1. I remember this question, so the question statement was not that vivid. This is a straightforward brute force solution. This has a straightforward brute force solution for 1 to x, right? And we can just check. No, we can just check that. So it can be 1 to minimum of x comma n. So I missed these conditions right here. All right. Anyways, let's get back. Find number of pairs in array such that ai plus aj is divisible by x and ai minus aj is divisible by y. I remember this was a modular problem. So something like this. This was ai plus aj, right? Modulo x is equal to 0, and then this was supposed to be ai modulo x, right? Plus a of j modulo x is equal to x, right? So this was one thing. So a of I modulo x was supposed to be equal to x minus a of j modulo x. I remember this problem. It was a good problem. Yep. So oh, I remember this one. This was a very good problem. Anyways, let's start with our first problem of the day. So turbulent times are coming. So you decided to buy sugar in advance. There are N shops around that sell sugar. The ith shop sells one pack of sugar for AI coins, but only one pack to one customer each day. So in order to buy several packs, you need to visit several shops. Another problem is that prices are increasing each day. During the first day, the cost is AI. During the second day, the cost is AI plus 1. During the third day, AI plus 2, and so on for each shop I. On the contrary, your everyday budget is only X coins. In other words, each day you go and buy as many packs as possible with total cost not exceeding X. Note that if you spend some amount of coins during a day, you can't use these coins during the next days. Okay, so we will lose that money. Eventually, the cost for each pack will exceed X, and you won't be able to buy even a single pack. So how many packs will you be able to buy till that moment in total? So each day, a shop can sell one pack to one customer, and we have X coins every single day. And using those X coins, we need to buy as many. We need to buy as many packets of sugar as possible. So number of shops and your everyday budget. Let's see. So 3 shops and I can buy 7. I have X equal to 7 each day. So I have 7 points each day. So 3, 7. This looks like a sorting problem to me, so let's just sort them. This is going to make us 1, 2, and 2. Now, on the first day, we can buy this, we can buy this, we can buy this, we can buy that. This makes us 3. Then this turns into 2, 3, 4. And in this case, we can buy 2 and 3, 5. Right? We can also buy 4 and 3, 7. But that doesn't make a difference. They are the same things, right? So this makes it plus 2. So we bought 2 more bags. Then this becomes 3, this becomes 4, this becomes 5. So again, we can buy 2 bags. Then this becomes 4 and 5. and we can buy only one bag, so that's one. Then we can buy only another single bag, that's what, that's one. Then another bag, that's one. Another bag, that's one. So we can buy 1, 2, 3, 4, 4 and 2, 6 and 2, 8 and 3, 11 bags. So this looks like a prefix sum problem to me. So what we are supposed to do is we are supposed to so what are the constraints? The constraints are x is 1e9. So let's build the prefix sum right here, 1, 2, and 2. So the prefix sum is going to be 1, then it's going to be 2 and 1, 3, 3 and 1, 3 and 2, 5. So initially, we will be able to buy all three of them, right? And then on our second day, we can also buy all three of them. And then on our third day, we can also buy all three of them, right? And after that, it's going to start getting worse, right? So we can buy this for how many days? We can buy these many. For 2 days until this becomes 7. Sorry, you can buy this for okay, I get it. So we can buy this for only okay, so each day, as each day passes, the prefix sum right here is going to be what? It's going to turn into 3, right? So the prefix sum turns into 2, 3, 3, and that is what? That's 1 extra here, 1 extra here, 1 extra here. So this turns into 8, right? That's the thing we need to understand. So the limit is 7, and if this is smaller than 7, right, this is smaller than 7. We have to check the number of days where this remains smaller than 7. So that becomes 3 into 1. 3 into x number of days is smaller than 7. So this is the ith index, right? Ith index times x number of days. Let's just call this k number of days, all right? So I times k number of days is smaller than or equal to 7. So a of I plus I times k number of days is smaller than or equal to 7. And this becomes what? This becomes 5 plus 3k is more than or equal to 7. 3k is more than or equal to what? 2, right? So k is more than or equal to 2 by 3. What is, in this case, we have 1 day only. And then we go to 3 now. We see, alright, is 3 So by the time we reach 3, we are going to add the previous number of days we had, right? So we had how many days have passed? 1 day has passed, right? So the current price of this becomes 3 plus 2 times of 1, because a single day has passed, and since only 1 day has passed, this becomes 5, right? And now we are going to say, all right, is 5 plus 2 times k smaller than or equal to 7. Now 2 times k is smaller than or equal to 2. Right? So k is smaller than or equal to 1, and we can do this for 2 days, right? We can do this thing for 2 days. So on the first day, or can we? Actually, it's weird to think about it this way. Let's start this over again. 1, 3, 5. 1, 3, 5. X is equal to what? X is equal to x is equal to 7. So on the first day, so when we are here, the current price is 5, and after k days, right, the price becomes a of I plus I times k. So after 1 day, this becomes a of I plus 3, and then on the second day it becomes plus plus 6, right? So we're going to find the ceiling where on 0th day, so k is going to start with 0 days, alright. So we're going to start with 0, first, second, third, and let's say that right now the value is 5. 5 plus 3k smaller than equal to 7, right? 3k is smaller than equal to 2k is smaller than equal to 0. So this only works for the 0th day, alright? It will fail for the first day after that. So once you come here, the number of days that have passed will be equal to number of days. It's going to be equal to plus equal to k plus 1. So after first operation, 1 day has passed, and once we come here, we will add to a of I plus equal to I times number of days, which makes it three plus 2 times 1, which makes it 5. So now our question is, after how many days does this become invalid? And the answer is, sorry, for how many days does this remain valid? And the answer is this remains valid for 5 plus 2k is more than equal to 7, and this remains valid up till 1 day, right? So k is more than equal to 1, which means this works for the 0th day and the first day. After that it stops working. So our number of days now turns from 1 to 3, right? And also, we can also keep track of the bags, right? The bags we scored, and that is going to plus just get incremented with I. And in the moment our value in the prefix sum gets greater than no, actually, we will start with the largest possible value, right? We're gonna go back and back and back. So the number of days, the value of x is 29, and the solution we devised is in O of n, so we should be safe. And then we sort this array. Then we will start our iteration with first thing we do is we increment this with sorry let's increment it with so the number of days I have passed, and we multiply that with the ith index. So the prefix gets incremented, and this makes sense. This makes sense to me. So if sum of I is more than equal to x. What do we do in that case? We check so the integer k is going to be equal to x minus x minus a of I, divide that with I itself, right? So x minus a of I divided by I, that gives us the value for k, and basically we increment our bags by I bags by k times, right? And we increment our bags by I times k plus 1. So this gets added up, and then we also increment our number of days with the value of k, and then we also go to the next day automatically, right? So it should so the first sum is see, so 212. On the first day, num days is equal to 0, and the prefix becomes 1, 2 and 1, 3, 3 and 2, 5. So by adding, let's write the indices here, 1, 2, 3. So the sum becomes 5 plus 3 times 0, which remains 5. Once we come here, we say is sum smaller than the value of x, which it is, right? So that's equal to 7. Now we check the value of k, which is 7 minus 5. 7 minus 5 is 2. 2 divided by 3 is 0. So this will work for 0 number of days, which means that the bags we collect are 3 times 1 number of days, right? So 3 times 1 number of days, we collected 3 bags for the first day. So our answer becomes 3. And the value of k is 0, I into 3. Number of days turns from 0 and remains 0 and then gets incremented the next day. So number of days becomes 1. And the answer is 3. So the number of days is now 1 and 3 turns from 3 and becomes 3 plus 2 times 1, which is 5. So is 5 smaller than or equal to 7? Yes, it is. What do you do in that case? K becomes x minus ai. So x 7 minus 5, that gives us 2, and we divide 2 by 2 itself, which means, you see, we are failing here. This is not working. We can work at best for the 0th day, alright? And then we can also work at best for the first day, because on that day we turn from 5 to 7. This will also work. But this is going to okay. So the idea here is that a of I gets incremented with I times k, and this still remains smaller than or equal to x. Right. So k is a 0-based number. Okay. That was it. That was the problem. We are missing some sort of edge case here, and I don't know. So let's reread the problem. Okay, okay. So the number of days only gets incremented. Yeah, the number of days only gets incremented um, when we find something and we choose something, right? Yep. Otherwise, we just go back and back and back until we find something right. So let's get to 1300 problem now. Given two arrays A and B of length n, elements of both arrays indexed from 1 to n. You are constructing a directed graph where edge from U to V exists if A of U minus A of V is greater than equal to B of U minus B of V. This is a graph problem, and we need to study graphs before we dive into this problem right here. So let's see what we can think about. So if there's a path from V to all other vertices. Let's take a break for a few minutes. So we have two arrays, and so AU minus AB is greater than or equal to PU minus PB. That is what? That is basically that is the entire thing, right? And if you look at here, if you look at this right here, this becomes what? This becomes So 3 minus 4 is minus 1. And then 1 minus 3 is again minus 1, sorry, minus 2. And then 2 minus 2 is 0. And then 4 minus 1 is 3. So this will point to what? So this will be 1, 2, 3, 4, right? Now 4 will point to all the elements. So it's going to point, sorry, it's going to point to all the nodes. So it's going to go to 3. It's also going to go to 2. It's also going to go to 1. And similarly, 3 is going to point to 1 and 2 only. So 3 is going to point here and here. And then 1 is going to point to 2 only, right? And 2 is the smallest, so it can't do anything. And 3 can't visit every node, right? Because 3 is going to go to 1. So let's see. 4 can visit every node. That's pretty understandable. Let's actually sort this. So minus 2, minus 2. Then we have minus 1, which is from 1, 0, and 3. And then we have 3, and then there's 4. So it's going to go to every node. Makes sense. Then we have this right here. Does this visit every single node? Now, if we go to 3, three will visit 1 and it will visit 2, right? It's going to go to 1, it's going to go to 2. But can 3 go to 4? Can 3 go to 4? And the answer is no. It can never go to 4. So the problem is so we can just sort this and see if the we can just see the number of elements with the same answer right here, right? So in this case, we have what? We lost it. Damn it. We just lost it, man. We need to fix our size. Just lost it. This makes much more sense. The canvas gets me lost, man. I get lost everywhere. What is semi-infinite? Okay, it's weird. I don't like this. Maybe it's good. It's nice. It's this instead. So in this case, this is 1. 1 minus 5 is minus 4. 0. 4 minus 3 is 1. Minus 2. 2 minus 1 is 1. So in this case, these two should be the answers, which is I equal to 1, 2, 3. So this right here. And the answer is, this was a very straightforward question. So is going to be so. What is going on with this right here? So what should have happened was that after we sort this, we get here, and then we stop. So the answer is supposed to be did we sort our differences array? We did. We did sort it. So the difference of first is equal to maximum of differences. We get our index I, which in this case is supposed to be Why is the answer 4? Why is the answer 4? What? बस हो गया टाइम. So why is this not working? Why are we not stopping at 1, 2, 3, 4? So it should have been 5 minus 4 and plus 1. We're getting a 0 instead. It's so weird. So our answer is not. मास में टाइम क्या है? Alright, guys, let's call it a day because I have some other work to do. Alright. Maybe let's try to attempt this problem, or I don't know. To find some of the answers to the problem for m pairs of rays. So we'll do this tomorrow, I guess. Alright, guys, let's end the stream now.